Okay, so I want to do example 12 from the example packet from chapter 4-42. Um, and in this one, we need to come up with an equation for this graph that's on the right. And you can just kind of look at it and see it's going to be a secant or cosecant one. So what I did was I already did really basic versions of the secant and cosecant graphs. Um, so let's take a look at our graph, the purple one over here, and analyze the features that we need. So stuff like vertical stretch, um, the period, which will get us the B, the vertical shift, and the horizontal shift. And the horizontal shift will depend on which function we're aiming for. So the vertical stretch here, well, normally it goes, these things go from -1 to 1, so a span of 2. But this goes from 2 all the way down to -8, so a span of 10. So it went from 2 and then multiplied up to 10, so it's a vertical stretch by 5. The period, I think the easiest way to tell where the period is looking at these asymptotes. So here's a starting point, and then the next time we repeat is over here, because then it starts that extra loop again. So that's a span from -2 to 4. That's going to be a period of 6. Our regular period is 2 pi. So if I divide 2 pi by 6, I'll get pi over 3. So that's going to be your B. Um, and if you're looking for horizontal shrink factor, that would be 3 over pi then. The vertical shift. So normally these things are centered at 0 for secant and cosecant. But if you look at this graph, well, since it's going from 2 to -8, right down the middle would be -3 here. Y equals -3. So this is a shift down of -3 units. So I'll say 3 units down. The horizontal shift, well, that depends on what we're aiming for. So we'll do 1 for secant. We'll do 1 for cosecant. So if we started with the secant graph, 0, when x is 0, it's right on the axis. So in this part, here's the closest one. That's at, if you notice, these tick marks are 0.5. So this is actually at -0.5 right now. So if I move my secant graph up here, whoops, if I move this graph 0.5 units over, then I'll get it in the right location now. So I'm going to move it 0.5 units to the left. If I wanted to get cosecant, well, what was originally at 0 is this asymptote right down the middle, and it's got a curve downwards and a curve upwards on the left and right sides. So that would be a lot like this asymptote here, I would say. Or you could do this asymptote over there. So I'm going to pick this one, the 2, the -2. And if I take my original asymptote as 0 that was up here and shift it over 2 units to the left, then I'll get the cosecant graph that I'm looking for. So let's write these out. The first one, the secant version, would be y equals 5 secant, and then I've got my b is pi over 3, and then I've got, let's see, x, and then I'm going 0.5 left, so that would be plus 0.5, and then 3 units down, so minus 3, and then the other one would be y equals 5 cosecant, and we've got the pi over 3 still, and then the x, let's see, plus 2, and then down 3 units. So there are 2 different forms you could get. If you wanted to try this just to see how you do with it, there is, I did come up with one other one just pretty quickly here. It's -5. So this is if you're looking for negative cosecant. Because sometimes it might be a little bit easier to aim for that, but it's not that hard to get the correct secant or cosecant one anyway. And this would be x minus 1 minus 3 again. So see if you can kind of understand why that works. And if you don't, start by flipping over this graph. Okay. So hope that helps. And that's going to be related to some of your homework problems. Okay.